staff engineer at Google. So Sierra and I actually first met each other at this conference as student volunteers when we were both babies and starting our PhD career. So I'm really excited to have you here and give our first talk here.
Thank you. And for the students in the audience who are at PLMW, you recall us all talking about how you will meet people as a student volunteer and they will be your peers later. That is exactly how this happens. So yes, I'm a software engineer at Google, okay, thank you. So I'm a software engineer at Google where I'm working on a team called Engineering Productivity Research. And our goal is to try to improve the productivity of the 30,000 engineers at Google and hopefully engineers outside of Google as well. So the mission of our team is to take this data-driven approach to understanding what makes software engineers happy and productive. Now, you might expect from this type of statement that in this talk I'm going to tell you about some productivity metric that we use to evaluate engineers. So I could say Shan's value to the company would be a certain dollar amount. And if you're hoping for that metric, I am sorry to disappoint you. That is not what we do. Because understanding the value of one engineer to another engineer to another engineer, measuring productivity along that type of lines, even along the lines of the whole company, that would be like the whole field of economics. And I am not smarter than a bunch of people who have PhDs in economics. I don't study that. I don't think I can make us be able to take impact there. So then there's the question of how do we improve productivity without actually being able to have a metric to look at it. And the way you can understand how we do this within Google is to understand actually the formation of our team, Engineering Productivity Research. And this started because I was actually on a different team. I was on the static analysis team, along with Caitlin Sadowski, who is also from this community, also was one of the student volunteers at that particular UPSLA. And she and I had been complaining for a couple of years about how we didn't feel that we were always using the best approach to understand and our VP had known that we had been complaining along these lines for a couple of years, and at some point our VP appears in our cube and she asks us an interesting question. She explains that to us. Effectively, she has this problem all the time where she can't figure out how to manage her resources. So the build team comes and says, if you give me 10 people, I will make builds twice as fast. The Java team comes and says, if you give me 5 people, I will improve the state of refactoring tools. Meanwhile, the code review team says, we need 4 people and we're going to improve code review. The code browsing team says they need 5 people. And she's going, I don't have enough people to go around. I have limited resources. So, she asks us, how do I know what tool and infrastructure investments to make? And this is actually a much easier question to answer than measuring productivity of individual engineers or even a group of engineers. Because this is a question about trade-offs. It's about relative trade-offs of do we do this work versus that work and relative prioritizations and how much they each cost and what's the potential benefit for them. We don't need to know what the baseline productivity is of Google engineers. We just need to know how much can we increase it and how much will that increase cost us. So we're going to try to improve productivity rather than measuring it by not looking at it as a whole, but making this problem a little bit smaller. We identify a pain point or some sort of productivity sink, and then we create metrics to figure out how much time is wasted both on an individual level, and then we scale that up and say, and how many times does that happen across the entire company? Create these metrics, and this allows us to now measure progress over time, and then we can use qualitative research to suggest improvements for how we would actually fix this. So in this talk, I'm going to be tell you about how we focus on these kind of smaller scoped questions with very actionable goals that we can change. And I'm going to introduce a metrics framework that we've developed called Quants. This allows us to figure out what metrics we actually want to use to measure things. And We get our metrics from actually two sources primarily. One is a bunch of logs data that we use to measure behavior, and then we use our longitudinal surveys to create metrics about developers' beliefs. Finally, we do a lot of qualitative studies to provide the narrative and make recommendations. And it's worth noting here that this team that we've created and started with only a couple of people has now become a team of 14 people. We've got half the team is software engineers, including several members from this community. And then the other half of the team are people called user experience researchers. They come to us with lots of different qualitative and quantitative methods, and they come from all different fields within social science. Everything from behavioral economics to cognitive psychology, engineering policy, data science, and HCI actually as well. And so they bring this kind of wealth of methods that we can use to be able to figure out the recommendations that we need to make. So, I know this is a research conference, and some of you who know me know that I like to give more interactive styles of presentations. I know you all have opinions about productivity, and you all have research ideas and things you're working on. I would like you all to stop for a moment and think about a question that you have about productivity. And either write it down, or, since there's enough people around here, I would like you to turn to your neighbor and tell them what your idea is. What do you think you are going to do to impact productivity? Okay. So, I'm not going to call on people. I'll let you keep your ideas to yourself there within your groups. So we get questions like the ones you've just shared all the time within our group. These questions come from tools teams within the company. They come from engineers. Sometimes they come from VPs. And the first thing we ask when people bring us a research question is this an actionable question? And obviously, as we talked about the keynote, actually the keynote speaker used the term actionable and said, well, everything is actionable, which is true. Everything is actionable. There's a question of whether it's likely that we would ever take action. So as an example of something that Google would probably never take action on, I'm not going to go into the religious war of whether we should use Vim or Emacs. We're going to support both. We're never going to deprecate one. It's not worth looking at. It would just cost too much to switch people over. And it would make them unhappy. This is just not worthwhile. So our team generally tries to avoid these types of religious wars that only are going to anger people and are not necessarily going to resolve anything. So we look at what is the action that could be taken here. We then ask, who is the person who would actually take action? And are they actually part of the conversation? Or is this a random engineer in a different part of the company who can't actually do anything about the problem? If we can get the right stakeholders involved, we can get the people who can actually take action, we start looking at what form of the data will convince them to actually change. As much as everyone likes to believe that they are data-driven, sometimes people are not data-driven. Sometimes what's more impactful is some sort of qualitative narrative to that individual. On the other hand, I've also seen individuals who just do not believe survey data, no matter what. They don't believe that surveys are a proper representation of what's actually going on. So for those people, we need to do more quantitative methods. So trying to understand who the stakeholder is and what kind of method would convince them and how much data would actually be needed. And finally, we ask, what will you do with a negative result? And this actually gets rid of a surprising number of questions. So for example, our test infrastructure team came to us, and they had a change that they wanted to make to the testing platform. it was definitely not going to be negative productivity. It was going to be negligible improvement to productivity to very positive. But they weren't sure where along that spectrum it would lie. And so we said, okay, so obviously if it's positive, they're going to turn on this feature for all Google engineers, great. So we said, what if it's negligible? Would you go and implement this thing? Would you use those resources? Or would you kill the project? And they go, oh, we're going to do it anyway. And I'm going, why? Why would you spend the time to do it anyway? And they go, oh, well, it actually has this huge resource improvement on our compute resources. So even if it made no change to the developer productivity, we're still going to save a whole bunch of machines. Going, well, that's great. Go do it then. This is otherwise, we're just measuring this as a purpose of some sort of vanity metric to maybe improve your performance reviews, but it's not actually going to change your decision making. And given the number of requests we're getting, we're looking to try to answer questions that will actually change decisions. So I'm going to give you an example that we're going to walk through here of a project that we worked on. We're going to focus on this question of readability. So for those of you who aren't familiar, Google has this slightly strange process around code reviews. And that is that all code, in addition to going through a normal code review process, must be either written or reviewed by someone who is an expert in that language. Now, to become an expert in the language, you go through a process called readability. You submit lots of code to someone who is one of the readability reviewers. After many, many attempts, they decide that you have now been blessed. You are now an official Java programmer at Google, and you may now continue without having to have somebody watch over your shoulder on this, at least for that language. So this process has been around at Google for a very long time and historically provided a lot of value. But there were some questions beginning to be raised about this process. It is very onerous. It's painful to go through. People generally don't like going through it, and people don't like necessarily the whole process of having to support everyone. It takes up a lot of time. And in the meantime, since this process was created, the world has changed. Even from the time when I started at Google, we got auto-formatters that work amazingly well. We have these linters and static analysis tools that are automatically finding all these little defects in your code that normally a readability reviewer would have been catching. And so in the presence of this new world, there became the question of, well, why are we still doing readability? Are we just holding on to it because it's some sort of weird hazing ritual that we all have to go through? And I liked that we're looking at this because that shows that we can actually possibly make change in this new environment, this new context. So the question came up, does readability even have value anymore in this new environment? So we go through the normal process. Is this actionable? Sure, we can take action on this. What's the form of the data that we need? We actually were able to talk with the readability teams. They sat on our floor along with the language teams, and they said, yeah, we've done some of this before. They'd had some survey data, and they liked survey data, but their own surveys they had run, there was some bias in them. They weren't certain if they were really correct, so they wanted maybe some improved survey, but also they're really looking for quantitative data at this point, given that they already had some simple survey data. So we said, okay, great. So let's go on to that last question then of actions and what kind of actions you're going to take. So if it's a positive, if it turns out the readability is useful, we asked, what are you going to do? And they said, well, clearly we're going to document this to stop all the arguments that are always happening across the company about this and save people the time. And we're actually going to invest more into this process then. We'll improve it further. We want to identify what the pain points are, what are the blockages that are causing productivity hits, and let's really make this thing move smoothly. And we said, okay, so what if it's negative? What if it turns out the readability isn't useful anymore? It's just a time sink. And I have this great quote from one of the language leads. If readability were found of negative value to Google over the long term, I would push strongly to kill it. And this is what I want to hear when I'm running a study, so we're going to go try and kill readability. As mentioned, I'm not trying to create a single metric here. Our team is not interested in making one metric that captures everything. We don't believe we can do it. And a lot of this is because this concept of productivity encapsulates many significant trade-offs. It's not one concept. It's actually lots of concepts put together. This is best described by one of my teammates who has this quote, I can increase the velocity of Google engineers by removing code review. which is true. We could definitely increase people's velocity at the cost of quality. We could perhaps increase both velocity and quality by just making all the engineers work 60-hour weeks. That would decrease satisfaction, which would of course hurt productivity when everyone leaves the company. So there are these implicit trade-offs in how are you going to study productivity. You can't just turn up one dial at the cost of others. So we can't have a single metric. This implies we're going to have multiple metrics for each of these aspects and each of these trade-offs. So the way we've done this is after running several of these types of studies, we started finding that there were really kind of 5 components to productivity that we were commonly creating metrics for and commonly asking questions about. So we've put this into this little acronym called Quants. The 5 we've come up with are first the quality of the code base. The second is what we're calling attention and flow. This is how much do engineers context switch? How much time are they spending in the zone, being able to code without interruption? We have one category here called intellectual challenge. This captures the essential complexity of the problem they're working in. The fact that an application like search is a much more complex beast than a very simple service that's only used internally. We've also got tempo and velocity. How fast can somebody make changes? How fast can they move? How many features can they produce? And then finally, satisfaction. How happy are they with their job and themselves? Now, to actually create metrics, we don't just simply go through these 5 and create a metric for each one of these 5. We use a goals, signals, metrics style framework. This is not produced by us. Goals, signals, metrics is used by a lot of other places as well. This comes out of business. And so for each of these 5 categories, we identify for our question, what is the goal here? What are we trying to help our users do? What's the kind of problem that we're trying to solve for that category? And then for each goal, we're looking at what's the change we expect to see in user behavior that would indicate that we've been successful in achieving that goal. I will note there could be multiple signals for each goal that we would see, but I want to also point out that a signal is not a metric. This is the change that one would actually see, but not the change you're going to measure. The metric is the thing you would actually measure. And so you'd have a metric for each one of those signals. And this could be any number of things that you might measure. This could be logs-based, survey-based. We count both quantitative and qualitative data as metrics here. So I'm going to walk you through this readability example now. I'm not going to go through, obviously, all of the different aspects of quants. So I've picked out just one here, tempo and velocity. But first, you've already picked out a research question, so I want you to take a minute to think about what, for that research question, is your goal in improving just engineering velocity. And it's okay, by the way, if you think your question doesn't really have to do with engineering velocity at all, that's fine. Sometimes we do have research questions that don't hit all 5 of those components. So if that's the case, go ahead and pick another one. I'll give you a minute to talk amongst yourselves and see if you can do this. Oh, yeah. This one? Oops. That one. Okay. So for readability, for tempo and velocity, our goal was that engineers will have higher velocity as a result of going through the readability process. They should be able to work faster. We're then going to go and pick on what is our signal now. I will give you another minute to think of what's the signal for your goal. So, and this is, by the way, I want to note, this is not the metric again. This is in the ideal world where you had perfect information. What's the thing you would measure? Okay, I want a quick show of hands. How many people picked lines of code? Yeah, a couple. So this is actually why we go through this exercise, is because lines of code is a great example of a metric that's not actually a signal. It's something that's really easy. It's also like the most popular one people use when they're trying to measure something, because it's so easy to count. It's always there. But it's a metric, not a signal. So to give you kind of the example of what I'm looking for with a signal, for readability, we have 3 signals here that our engineers would actually be working at a faster pace. One was that we said we want to see that changes that are written by engineers that have been granted readability are actually faster to review for the normal code reviewers. We also want to see that the engineers themselves are actually having a faster time producing that code, and in particular shepherding that code through the code review, because their code already has somehow met this readability standard. And finally, we wanted to look at whether engineers that have been granted readability judge themselves to have higher velocity. Now, these aren't necessarily metrics. These are signals. They're the thing we want to have measured if we had perfect information. Some of these are going to be harder to actually measure than others, though. And this gets into like, how do you select a metric? It's really easy, as I said, to select the metrics that we can measure, something like lines of code. But the problem with doing that is you end up in some really weird situations if you just start with your metric first. So we had actually an example. One of my colleagues on another team, he came to us and said that he wants to measure, it was kind of he wants to improve code complexity. And because he was just looking at the metrics he had available, he ended up in this weird space where he wanted to improve code complexity, and this ended up with him measuring the number of comments in a code review, because at Google that's another easy metric to get, like lines of code. And when you look at this afterwards, you're like, wait, why did we end up here? And the reason why was simply it was the metric that he could get, but not necessarily the one that he wanted. So keep in mind that a metric is always kind of a proxy. It's a proxy of the underlying thing we want to measure. It's not going to be a perfect proxy, and it's good to understand at what point is it good enough. If it's not good enough, should we just abandon using it entirely and say we just don't have maybe a metric for that signal? That's okay too. But we need to select, if we can, the best possible proxy for our signal. So given your signals, or if you're not liking your signals, feel free to think about the ones I've already shown you. What are the metrics that are available to measure each signal? And how close can you get to measuring that signal? Additionally, you might need to then find that you need to create a new metric, that there is no metric out there that measures that. And I will note here, qualitative metrics do count as metrics. I'll give you one more minute. This will be the last one, I promise. Yeah, go back a slide to the signals. Okay, so I'm going to bring you all back. We're going to look at now what the metrics are that we've got. So the metrics that we came up with, we've got one for each signal, and you could maybe, again, have multiple per signal if they aren't quite the best proxy and you feel like you need 2 metrics to try to triangulate on that signal, or maybe even more. We've got the active reviewing times, the metric we've created that looks at how much time the reviewer actually is spending in the review tool or in related tools trying to review this change. We've got active shepherding time per change, which is the amount of time the author spends both in the tool responding to comments, but maybe also making the changes, looking up documentation. And finally, the proportion of engineers who rate themselves as satisfied with their own personal velocity. So where did those metrics come from? Some of those seemed like crazy weird things that you might not be able to get. And we actually use a lot of different methods within our team. As I mentioned, we're half software engineers, half UX researchers. And we measure behavior first through a lot of our quantitative methods. And this provides us with a lot of impact and large N. We can measure easily everyone across the entire company and find out what engineers actually are doing in practice every single moment. So to do this, we use a lot of tool instrumentation. We use source repository mining, as I'm sure many of the members of this community do as well. We even do causal impact analysis, and once in a while, we can even run an A/B experiment. However, to measure something that's not behavior, but about beliefs, that's where qualitative methods come into play. And this doesn't provide us with large N. Maybe with surveys, we can get some large N, but with things like interviews and diary studies, you're talking a much smaller number of participants in a study, but you can provide a very rich narrative from this. And this is where we can find out why engineers are doing what they do and what kind of problems they're actually coming up from this and what recommendations can we make to improve things. Now, we said we use a lot of different methods. I'm going to talk about 2 of these in more detail, which is our tool instrumentation and our longitudinal surveys. Those are kind of our 2 primary sources that we use for metrics when we're doing this type of analysis. So I'll talk about our tool instrumentation first, but before I get into that, I will note we are at a very unique environment at Google. There's several things that enable the type of instrumentation and surveys that we do. First, Google developer tools are nearly entirely developed in-house. This is because the external tools, including some of the open source tools, don't actually scale to the size of code base that we have. And the ones that do were frequently written by us. So we make a lot of our own tools, and because it's Google and we really have one big hammer that we like to use, we build services, so all of our tools are services, of course. And because we make services, of course, make lots of logs, so we are very good at logging our services. And then, of course, we've got lots of tooling for processing all of our logs. And also, nearly all of our developers are using the same exact development stack. This is going to make instrumentation actually possible. We've got 2 other unique kind of things, though. One is that Google engineers are very engaged and reflective practitioners. They think all the time about how they can improve their own productivity. How can they improve their team's productivity? How about their org? They're always looking for ways to improve themselves. And they really, really like to complain, especially when you give them a platform that's sitting within the developer tools group. They will write you essays. So let's talk about how we actually collect logs. This is now, as I mentioned, a very large code base. We're currently at about 3 billion lines of code, 30,000 code reviews a day, 1 million builds a day, and 500 million test cases run every day. And it's all instrumented. So we can, for example, the level of instrumentation we have is every button click in our code review tool. We know every file save. We know every time someone clicks within our code browsing tool. This is all available to us. Our build and test logs, of course, for all of those ones that were run, and then many other things as well. And what this can give us in combination is effectively a picture of what a developer is actually doing. So it provides this kind of comprehensive view. And then we actually can confirm that our logs are correct using qualitative analyses to see whether the metrics we're producing are actually aligning with developers' perceptions. And I will note here that in the cases when they have not aligned, it has almost always been that the logs and metrics were wrong, not the developers' perceptions once we dig into it. What this allows us to do then now with those kind of picture, when we have to have a picture of developer's day, we can now create metrics from that. So, for example, I mentioned this active shepherding time, the amount of time an engineer spends pushing their change through the review process. And this is capturing the time, not from the time they start the process to the end wall clock time. This is actually the time they're spending in the code review tool, iterating with the reviewer, responding to comments. It's the time looking up documentation. It's the time spent coding to respond to those comments, looking up all their test failures as they're iterating through this process. That's all going to be captured here. But we're going to be able to capture it now without all the weekends and holidays and evenings and time even spent at work coding, but not on that particular change. Now, I will stop for one moment and note this is kind of craziness. And we absolutely do not use this for evaluating individual performance. We, in fact, don't even let engineers look at their own logs for this reason, because we don't want people to actually get coerced into this. Our goal is not to try to identify engineers and look at their own improve performance for themselves. Our goal is to improve the productivity of everyone. There is no looking, for example, at Jeff Dean and Sanjay Gemawat and saying, this is how they do work, and so therefore I will try to emulate them. I am never going to be Jeff Dean or Sanjay. That's not what I'm going to be able to do. So I'm not going to try to make me into them. I'm going to try and make me the best me by improving our tools so that we all get better. So for readability, this is how we got our top two metrics here, this active reviewing time and active shepherding time. Now we had this one other metric at the bottom here about people's satisfaction, and we have that because logs alone don't tell us the whole picture. And to emphasize this point, I'm going to give you one fun fact from Google's logs. The median active reviewing time per change is 5 minutes, which seems like a really interesting fact until you realize that you have no idea what that means really. Is that good? Is that bad? Should it be longer or shorter? And which changes is that including? And what size changes is Google producing? And is it just, are we including documentation in that number? Are we including whether or not people have readability? You don't know from just the logs whether or not this is a useful number. Which is why we then ask people qualitatively about their velocity. We can now then say, okay, this number is the number that says people are feeling like they are, in fact, working at a high velocity. So to be able to do that, we have a longitudinal survey that we're running. This is a quarterly survey where we are sampling a third of engineers every quarter, that is every 3 months. The survey is very long. It takes about 25 minutes to complete. It can be hundreds of questions, but only certain questions are shown to certain engineers. And we're actually getting about a 40 to 50% response rate right now on that survey. And we have questions like the one that I mentioned here. So how we ask people how satisfied they are with their own engineering velocity at Google. So that combined gives us this whole picture now. We have our goals, we have signals and metrics, and we get a whole bunch of these metrics now for each of those components. And then we go evaluate to see what happens as somebody goes through the readability process. Does that, in fact, improve productivity? So, putting this all together, can I kill readability? And I can't. It turns out this process is, in fact, still useful. This was rather disappointing to me because I really wanted to kill something. But actually, what we found was that it increases people's self-perceptions of their code quality, and it had a really positive effect on reviewing and shepherding times. So what you're seeing here in this graphic, the blue is people before they go through readability. There's changes at times. The green is during, and the red is after. And what you'll see is, in fact, yes, it does go up during because they're having to spend more time addressing these readability comments. But afterwards, it drops back down below the level of where they were before. And this is also controlling for tenure and the size of change and the number of reviewers on that particular change. When we do all that, we find that the time is recouped. That cost of going up here is recouped about 18 changes later. So if you're planning on working on a particular programming language for at least 18 changes, we would recommend that you probably should have gone through readability. We then, from the qualitative work, though, found that people said this really provides mentorship for them, it spreads knowledge, and we were also able to identify some common pain points with this process, which the team immediately started addressing. So they started looking at things like improving the visibility of how somebody's going through the process and making it so that we don't have as long of a wait time to get into the process from the start. So summarizing up here, our process for improving productivity is we start by not trying to answer this question as a whole, but narrowing this problem down to smaller scope questions that each have actionable goals. We then use quants to try to figure out what are the metrics that we actually want to measure for a particular research question. And we're using logs data and survey data to create those metrics. And finally, using some qualitative studies, things like interviews and open-ended survey responses, to provide more of the narrative and identify recommendations for how to improve productivity further and reduce these pain points. I'd like to note here that also this is not work that I can do alone. This is a team I mentioned of like 14 people now. This is the type of work you do in a large research lab, and I have an amazing team. If you're interested in working on developer tools at Google, I know people who are hiring. Please come and talk with me about that. Thank you very much.
Readability teaches is a bunch of sort of groupthink regarding code style and code guidelines. But those guidelines are not actually useful. And so what the readability process teaches is sort of the standard agreed upon methodology, which is not useful. And so it does reduce time. It does reduce time spent reviewing because you don't get comments that you have to address.
Sure.
But those comments would not be useful. And people feel like they're making more progress, but it's just a placebo effect.
So one of the tenets that Google has had is that we prefer consistency within our code base above all else. And you can see this actually, so I've got a prior paper on our monolithic repository, and that was actually one of the things that came up in comparing monolithic repositories to a multi-repository system. In a multi-repository system, every team, every group is doing their own thing, and they're coming up with maybe style guides that make sense for just that team but don't make sense for other teams. And so it might be that a team comes up with the perfect thing for them, whereas in a monolithic repository, they would have to adhere to the groupthink. And what the Google engineers say is they actually strongly prefer consistency to having it be absolutely perfect. That good enough and consistent is what we're aiming for.
Thank you. I noticed that in September of this year, Google created a repository called Google Engineering Practice on GitHub. Right? So Google writes some articles about their engineering practices, about code reviews and change authors. And they suggest that code authors, change authors, should submit small and focused commits, which is very important to speed up the code review process. And I wonder what Google actually do to assist developers to avoid submitting composite commits, but submit focused and self-contained commits. Focused and self-contained commits.
The usual process within Google of encouraging that behavior is actually the code review process. I will just speak from personal experience that I have certainly had engineers send me a very large change before, and I immediately respond back with, that is a 1,000-line change. I am not going to look at it until it is broken up. And then you tell them to now break up that into multiple smaller changes, and that's considered an acceptable thing within the company culture to request that. To request that this please be broken up, and if not, explain why it can't be.
That can automatically...
They can automatically break them up?
Yeah, break the composite commits into smaller ones and classify them into like new features, bug fixes, and factors.
That would be cool. There is prior work on breaking up a commit, but not in the way that you're describing, where you might want to I think what you're describing is you'd want to take some large change and say, like, this is the pure refactoring, this is a minor bug fix that wasn't associated with the main feature I'm working on. That would be really cool. I don't know of any work on that. Okay.
I think I saw a hand there first. So this
I think so.
And then it's Switzerland, and then I think we're up. Yeah. So back there, please. Right here. Oh, are you not bringing the mic? Okay. Right here, actually. Oh. Okay. Well, then you next.
Sorry, can you hear me?
Yeah.
So, can you give us an example? Can you give us an example of something that you weren't able to kill or change that gave productivity gains?
Trying to think. Most of the things that we have actually killed effectively have not been killing existing things, but they have been stopping teams from working on something that was not going to be the most productive use of their time. I could give one concrete example of that. One of the languages teams came to us and they were trying to decide whether to improve. They were looking at testing in particular, and they were going to try and improve testing infrastructure. It turned out that our survey data said that testing was not the biggest problem, that they would instead be better off spending their time working on either refactoring or debugging. And so they changed so this wasn't like a process that we were killing off that was already in existence, but they changed their team's direction based upon that.
I think you, and then you have the last question. Yeah.
So you gave this like very elegant sort of top-down approach to figuring out what to do and how to go about doing it. I'm wondering, how do things go wrong in this model, and what do you do when things go wrong?
It's a great question. The things that go wrong the most frequently are, first of all, people jumping directly into metrics. At that point, when that starts to go wrong, we try to actually have a meeting to kind of more forcefully pull our stakeholders back into asking, what is your goal here? What are the signals we're going to produce? And we start walking them through it a little bit more rigorously. Another thing we've seen gone wrong is when this is on our end, if we have not been doing our due diligence to make sure that we know what type of data will convince our stakeholder, and that's why I had that point in there about how understanding whether or not survey data will ever convince them at all is good to know. Understanding whether logs data will convince them. Knowing where they stand on that and how much evidence they need to be able to change their mind. Sometimes it turns out that it's so much evidence that someone would need that it's not worth us doing, just because it would take our team too much time for the benefit that would be gained from making a decision.
Last question.
Thank you for sharing great experience. If you are back to surveys, especially response rate, it's 40-50%.
Yeah.
It means that actually engagement of engineers into these surveys are pretty low. So what do you do to improve response rate, and how actually you work with improving engagement of engineers? So in our organization, it's the biggest problem.
So 40 to 50% is normally considered.
The summary is that actually only 40-50% of engineers reply surveys. It means that this 40-50% are more active engineers, but another 50% just keep silence and don't provide talk. Either they satisfied or not don't satisfied. So we don't know, and how actually we can make all of them happy and productive.
So 40 to 50% response rate is generally considered to be exceptionally good for a survey. The first time our UX researchers, one of my colleagues is from the HCI community, and when she first ran a survey on Google engineers, by the way, she'd been a long-time Googler, has worked on many consumer products. Her first survey, she got 70% response rate and was astounded. And that was a small survey. So we do tend to get higher response rates for smaller surveys. This one's a larger one, so we're looking at 40 to 50%. She is usually floored by the numbers that we're getting on these. I will note the number is also probably a little bit higher than that, just because we do get, out of office messages and vacation responders a lot. So I'm not counting in those as well. We have tried several different ways of improving that number further, though, because we, of course, would always like a higher response rate. Most of this has been catering to the particular idiosyncrasies of Google engineers. So we will sometimes send out custom messages from one of the engineers to only the people, for example, who have started the survey but haven't finished it, because those are the people who are most likely to actually go ahead and complete. Using memes also apparently helps, because Google engineers love a lovely image macro. So yeah, there's actually, though, some work from Microsoft which talks about how to increase survey response rates within software engineering that we've used as well.